Hello, and welcome to this presentation, Getting Started with the LMG600 Script Editor. In this presentation, we'll provide an overview of how to create and use scripts on LMG600 series precision power analyzers. As we'll see in this presentation, values generated by scripts can be displayed directly in the Script GUI and/or in a user-defined custom menu. We'll only briefly mention custom menus in this presentation, so please see the separate presentation Getting Started with the LMG600 Custom Menus if you'd like to learn more about custom menus and how to create and use them. The Script Editor is a standard feature on LMG series analyzers and is primarily used to calculate values from measured quantities or measurands. These values can then be used in both standard menus as well as in custom menus. In addition, the Script Editor can also be used for other functions. One example is reading or setting the values of pins in the PSI and GPIO interfaces, both of which can be used to interface with external devices. It can also be used to save snapshot data and write sets of values to a log file. After being installed, scripts are executed continuously, once per measurement cycle. Note too that scripting is internal to the LMG. No external PC or additional software is needed to create and run scripts. In the remainder of this presentation, we'll walk through some basic examples of creating and running scripts, but please see the LMG documentation for more detailed information and examples. To start the Script Editor, press the Custom Hard key on the front of the LMG and then navigate to the Script tab. Creating and editing a script requires that Mode be set to Edit. The Clear menu item can be used to create a blank or empty script. Scripts can be loaded from or saved to the file system using the Load Save button, and these scripts are saved with the file name extension .zscript. The default Script Editor window shows both a virtual keyboard as well as a hints panel showing warnings and errors with line and column numbers. Both of these can be individually toggled on or off by going to More, Keyboard, and Hints. This is especially helpful when operating the LMG remotely, or when using a USB-attached keyboard. Note too that even if the Hints panel is disabled, small yellow or red notification icons will still appear next to lines with warnings or errors. Script Editor works much like most standard programming and scripting languages. Lines are either terminated by semicolons or by new lines, and commenting is done using the same conventions used in many other programming languages. The Script Editor GUI also has a helpful Undo-Redo button as well. Two types of variables are used in Script Editor. The first type is script internal variables, which begin with a $sign. As the name implies, these values are not displayed, and are typically used for storing scaling factors or intermediate values. Public variables, on the other hand, do not begin with a $sign, and these are displayed in the Script GUI when the script is running. Public variables can also be used in custom menus. One additional thing to know about public variables is that they can be accessed and used in the same way as regular measurands. For example, they can be graphically displayed or plotted. We'll look at an example of this later in this presentation. Variables can be declared either with or without the def function. The def function is used to define the units used when displaying public variables. For example, if we simply declare variables without using def, these values will be displayed without any units. On the other hand, if we use the def function when we declare these variables will be displayed using their units, here volts and amps. Note too that declared variables may also be initialized with values within the def block. Measured values or measurands, such as voltage, current, power, etc., can be used directly in Script Editor, or can be assigned to variables. These values are referenced by using a descriptive prefix and a 4-digit GCBT value, which stands for group, channel, bandwidth, and transformation. For example, the RMS voltage on Group 1, Channel 1 would be referenced using UTRMS 1111. These measurand names can be manually entered, But a more convenient way of doing this is by pressing the Insert Measurand button and then choosing a value from the graphical list of available measurements. This will insert the proper reference into the script at the chosen point. To begin running or executing a script, press the Install Script button. In most cases, the mode should be changed to View in order to show the public variables and their values. Recall that scripts are executed continuously, once per measurement cycle, and the values of displayed public variables will therefore also be updated once per measurement cycle. An installed script can also be enabled or disabled, and this can be used to pause the script without resetting any accumulated values. Next, let's look at a slightly more complicated example, namely measuring the efficiency of an AC to DC power supply. To do this, we need to measure the power being delivered to the supply by the AC mains, and we'll use Group 1 Channel 1 of our LMG to measure this. On the DC side, we'll use Group 2 Channel 1 of the LMG to measure the DC power delivered to an electronic load. Using these two quantities, we can calculate the percent efficiency of the supply by dividing the DC power out by the AC power in and then multiplying by 100. So our script for measuring efficiency requires two measurands, the AC input power, measured in watts, and the DC output power, also measured in watts. We assign the measured values of these quantities to their respective variables. Efficiency is calculated from the ratio of these two measured values, and will be displayed as a percentage. Note that here we're using def in order to display these public variables with appropriate units. After the script is installed and mode is changed to View, the values of AC input power, DC output power, and efficiency will all be displayed with their appropriate units. These values will also be updated with each measurement cycle. In addition to showing their numeric values, public variables can also be plotted. This is done by selecting the desired value from the type group, Script Varies, under the Plot tab. In this example, we can see that efficiency decreases, first slowly, then more rapidly, as DC output power decreases. As mentioned earlier, public variables can be accessed and used in the same way as native measurements made directly by the LMG. Script Editor also supports program flow or execution control using standard if-else type conditional statements. The executed code can be either single statements or multiple statements enclosed by curly brackets. Another type of flow control is loops, which is implemented by using standard for-style loops. Please note that the entire for loop will be executed once during each measurement cycle. A common application of loops on the LMG is stepping through lists of values, such as harmonics. Again, please see the LMG documentation for more details about how to use conditional and/or loop statements. Script Editor also supports various built-in functions. In addition to mathematical functions, such as sine, log, max, min, etc., special functions exist for starting, stopping, and resetting the energy counter, logging values, executing configured actions, such as taking a screenshot, and setting the state of pins in the GPIO and PSI interfaces. We won't go into these functions in detail here, so please see the separate presentations on each of these topics to learn more about how to configure and use them. One of the more powerful applications of scripts is using scripts together with custom menus. Custom menus are a more flexible way of displaying calculated values compared to the simple table or list we saw earlier. In addition, scripts and custom menus can interact, with buttons or controls in the custom menu controlling script execution and behavior. Please see the separate presentation, Getting Started with the LMG600 Custom Menus, for an introduction to how to configure and use custom menus. Let's end with a brief summary. The Script Editor feature allows scripts to be created and executed directly on LMG600 series analyzers without the need for any external PC or software. The most common application of Script Editor is calculating or deriving values from measured values or measurands. For example, using measurements of input and output power to calculate the efficiency of a power supply. The numerical results produced by Script Editor can be used in the same way as other measured values, and can be displayed, plotted, etc. in the same way as well. Script Editor also has a number of useful features, including user-defined variables and units, and easy assignment of measurands to variables. Conditional if-then statements and for-style loops are also supported, along with a variety of built-in functions. And lastly, scripts can also be used together with so-called custom menus to further enhance and customize the calculation and display of measurement results. This is covered in a separate presentation. This concludes our presentation, getting started with the LMG600 Script Editor. If you'd like to learn more about the LMG, power analysis, or related topics, please see the links in the video description. Thanks for watching. Please subscribe to our YouTube channel and visit us at rody-schwartz.com.